Now let's apply what we learned about CAPM and beta to the case of portfolios. So instead of individual stocks, let's look at application involving multiple assets. So for example, what is the expected return of the following portfolio if the risk-free rate is 1% and the expected market risk premium, again, always very careful with the information given. Is it the expected market return or is it the expected market risk premium? Here it's the expected market risk premium is 5.3%. So here we are given two stocks, A and B. So this is a portfolio. We are given how much we are investing, 40,000 in A, 60,000 in B. So this will allow us to compute portfolio weights. And we are given the individual betas, 0.8 for A and 1.3 for B. So there are a couple ways we can approach this, as discussed in the book. One is we could use CAPM for both A and B separately, find their expected returns, and then combine them, find portfolio expected return as the weighted average of individual expected returns. So that's one way we can do it. But we would have to apply CAPM twice, all right? Once for stock A, once for stock B, and then combine. Alternatively, we can use this really neat property of portfolio beta, of beta. It's really nice compared to, very different from Sigma. Remember, Sigma portfolio with just two stocks, for example, was this messy thing. With more stocks, it was even much messier. We didn't even cover it. But with beta, it's just weighted average of betas, regardless of how many stocks there are in the portfolio. It's just weighted average. Okay, so we can find the beta of the portfolio and then plug that in CAPM just once and find directly the expected return of the portfolio using CAPM. So let's do that. Okay. So let's find first the portfolio beta. For that, we need the portfolio weights. What are the portfolio weights? The weight of A is going to be amount invested in A, which is 40,000, divided by total amount invested, which is 100,000. So that's 40%. We have 40% of our money in A and 60% of our money in B. So the portfolio beta will be dictated in the same proportions. A will contribute 40% and B will contribute 60% to the beta of the portfolio. So beta of the portfolio is weight of A, 0.4, times beta of A, 0.8, plus weight of B, 0.6, times beta of B, 1.3. Crunch the numbers, we get 1.1. So this is a relatively risky portfolio, about 1, right? Riskier than your market or the average stock. And this will be reflected in the CAPM expected return. So let's plug this in the expected in CAPM formula. Instead of individual stocks, we are doing a portfolio's expected return. So the RP, portfolio return, is risk-free rate, which the question tells us 1%, plus the beta of the portfolio we just found, 1.1, times the expected market risk premium, which is directly given by the question, which is 5.3%. And that gives us 6.83% should be our expected return from this portfolio of two stocks. Okay, let's do another example, slightly different. Now, what is the expected return of the following portfolio? Now we have three assets here, and risk-free rate is and expected market risk premium are the same. Now in the table we are given there's one stock. We are investing $1,000 in that stock. We are given its beta 2, quite risky. So it moves twice as much as the market in that direction on average. So if the market drops 1%, this stock tends to on average go down 2%. There's something called market index. So think about, for example, an index fund, S&P 500 index fund, for example, which is a very common investment vehicle. We are putting $6,000 in it and the beta is not given. And then we have the risk-free asset. Think, for example, 10-year treasury notes. We are investing $3,000. So think about lending $3,000 to the US Treasury. And the beta, not given. So now here where these concepts are important, don't be surprised. We actually know these betas. They don't need to be given to us. A market index like S&P 500, remember what's market's beta is? 1 by construction. So an index fund or an ETF, exchange traded fund that tracks exactly the performance of the market or S&P 500 index will have exactly that same beta. So we know the beta of the market index has to be 1, and the beta of the risk-free means beta of 0, right? So market index's beta is 1 and the risk-free assets beta is 0 by definition. Okay, So what do we do now? Let's again compute the portfolio beta, and then let's plug that in CAPM. The weights will be, the weight of the stock in our portfolio will be 1,000 divided by total, which is 10,000. So that's 10%. Weight of the market index will be 6,000 in the market index divided by 10,000 total, 60%. And the remaining 30% is the risk-free. And portfolio beta is going to be weight on A, the stock, 0.1 times beta of A, 2, plus weight of B, say the market index, 0.6 times beta of the market index, 1, plus weight on the risk-free asset, 0.3 times beta of the risk-free asset, 0. That term goes away, right? That's 0. Something times 0 is 0. So we are left with 0.1 times 2 plus 0.6 times 1. So that's going to be 0.2 plus 0.6, 0.8. So a relatively safe portfolio. Even though we had the stock with 2, beta of 2, we had a low enough weight on that risky stock and high enough weight in the risk-free asset that we were able to achieve a portfolio with relatively low risk. But no free lunch, relatively low systematic risk means also relatively low expected return. Plug this in CAPM. Risk-free rate is 1%. Plus beta of 0.8 times the expected market risk premium of 5.3% gives us 5.24% expected return from this portfolio.